A lot of times when we're given these problems, we are only given the derivative. And this is a very straightforward question where it says, hey, here's the derivative, find the x-coordinates of the maximum and minimum, maxima and minima. And just realize that that's not ever what a problem in our class is going to look like. It's going to be a little bit more complicated, and you'll notice in example 7, that's a little bit more of the types of problems we're going to be seeing on tests, on practice, and all of that. But let's just practice the bare minimum of what this is. So here's the derivative, and it says just find the x-coordinates, which is all we can do right now. We can't find the y-coordinates of the maxima or minima because the only thing we have is the derivative, and we right now, only have one way. We only know how to find the derivative. We don't know how to undo the derivative yet, but we will learn it eventually. So we want to find all the x-coordinates of the local extrema, which is your maximum or minimum. In order to do that, we need to first take our derivative and set it equal to 0. So we've got x squared minus x minus 6 equals 0. In order to solve for quadratic, when it's set equal to 0, we have to factor it, or we can use our calculator to help us find the roots. I think we talked about this last class, but I don't remember. So what we have is we could factor it, right? We're looking for two numbers that multiply to 6, negative 6, and subtract to negative 1, which would be negative 3 and positive 2. We could also use where our numerical solve is in our calculator. So go to algebra, polynomial tools, find roots of a polynomial. This has a degree of 2 because that's the highest exponent we have. And then we can plug in, okay, what's the number in front of x squared? It's 1. What's the number in front of x? It's negative 1. What's just the number? Well, that's negative 6. And it solves it for you. Or you could have done, okay, that's x minus 3 times x plus 2 equals 0, x equals 3, x equals negative 2. Or, okay, it gives it to you. Okay, now we make our sign diagram. Plug in the easiest number we can think of, which will be 0. 0 minus 6 will be a negative number. And then it just alternates from there. Sign diagrams can be really, really, really quick, so they can be pretty helpful. So we know our x values of our local extrema. We know that this is where something will happen, and we know that this is where something will happen. We just don't know if they are a maximum or minimum. So we use our sign diagram. Negative 2 must be a what? Negative 2 is a maximum. We went up first and then we went down. 3 must be a what? 3 is your minimum because we went down first and then we went back up, creating a bowl as opposed to a mountain. Okay, so as straightforward as it's going to get, this doesn't look anything like most problems we talk about in this class because our problems are typically a lot more complicated. And so we can take a look at the back and see, oh, this looks a little familiar. Scary, but familiar. And so let's take a look at what this is asking us to do. A fruit distributor has noticed that the weekly change in the price of apples can be modeled by this function, where PC is the change in the price of a kilogram of apples, and X is the number of weeks since the start of the year. So it says a fruit distributor would like to plan a sale when the price of apples will be at a minimum. What week should the sales be? So highlighters, for those of you who like to highlight things and stick out like nice words. So a nice word here is minimum. That means that the derivative equals 0. We'll have to create a sign diagram and take a look at okay, was it positive and then negative or negative and then positive? Either way, that'll help us figure out where the minimum is. Also, take a look at what these variables stand for. X is the number of weeks, so we know what week means X equals question mark, right? What week? X is the unknown here, so we're solving for X. Okay, and then our PC. PC is the change in the price of a kilogram of apples. And I want you to notice this really key part of the definition. Change. Okay, so your PC is the change in the price. It's not the price, it's the rate of change of the price of apples, which means that PC is the derivative function. Change in price, rate of change, right? So seeing things like change or a rate or a slope, I know we've got a ton of words, and hopefully we can have like maybe a word bank in our classroom of all the different ways we've seen referenced to derivatives, but it's another way of referencing to a derivative. So this is the only function that we have, and it asks us, when will it be at a minimum? Okay, so we want to know when this guy is equal to 0, and specifically, we want to know when the minimum is when we had a negative slope and then a positive slope. So our sign diagram needs to look like that, an angry person. Okay, let's graph it. Dun, dun. Negative 13 divided by 52, well, times sine of 90 divided by 13 times x minus 5. I'm going to fit this, and it's going to look a little bit nicer. So this is a trig function, and remember with sinusoidal trig functions, it looks like waves that go around, right? And normally with trig functions, with untransformed trig functions, we say between -1 and +1. And so it tends to be really zoomed in on the y-axis and really zoomed out on the x-axis. And so zoom fit with sinusoidal functions are going to be super helpful. Remember, if you click and hold in the white space, you can also then like drag this around like you would be able to like on a computer screen. Okay, so we want to know when this derivative is equal to 0. And we have a few places where it is. It's equal to 0 here, and it's equal to 0 here. If your trig function doesn't look like this, take a quick second and look up here. If it says radians, remember we don't ever talk about radians, so we want it to be degrees up here. So make sure that you change it to degrees if it's not. Okay, I want to know what my x-intercepts are, so I'm going to find my zeros. Lower bound just to the left of it, upper bound just to the right of it. Remember that you can't highlight both x-intercepts. You have to do one at a time, or else it will only give you one. So now I have to go over here and do it again. And that's 31. Okay, so since this is the derivative function and we're trying to build a sign diagram to talk about this derivative function, we need to look at whether the derivative is positive or whether the derivative is negative. That's all we care about. We don't care about whether the derivative is decreasing or increasing. The only thing we care about for now is that it's at the positive or it's at the negative. Okay, so below 5, we know that the derivative is above the x-axis, so it is positive. Okay, between 5 and 31, it's below the x-axis. Okay, so that means that the slope of the original function is negative. After 31, it becomes positive again, and we stop there. We know with sinusoidal functions is going to continue to intercept with that x-axis, but that's okay. All we care about for right now is just this little window of time. Okay. So since we want to know the minimum, where it will be, x equals what to find the minimum? We're looking for, remember, a decrease and then an increase, which means that 31 is your minimum. So how we talk about it is we say in the 31st week, the price of apples will be at a minimum. Okay, Sales decrease when the price of apples approaches its maximum. In what week will the price of apples be at its highest? So maximum is when we have an increase and then a decrease when we set our derivative equal to 0. And so that will be at 5. The price of apples will be at its highest in week 5. Okay, so just moving a little bit closer towards the direction of what these types of questions that we go through are. We're talking a lot about these types of word problems, and knowing when your function is the derivative, it won't always tell you. You have to realize that in the naming and the labeling of what this function is, you have to know, okay, if we're talking about change or a rate or a relationship between as this change, how does the other one change? That's going to be your derivative function because we're talking about a slope, right? Versus your original function. And so being able to spot that out, use your sign diagram to kind of boil down the bare essence of what's happening and then be able to answer questions like this. Okay, awesome, good job.